told my joke already for the day. So, so anyway, so the first thing this is 5-5 and it's double angle and half angle formulas. So 5-5 is first we're gonna talk about the double angle formulas and then we're gonna talk about the half angle formulas. So double angle formulas. I told the other class that where you have to memorize the sum formulas, okay? I write better on the board. You don't have to memorize the double angle formulas. But what they say is sine, so the first one says that sine of 2u is equal to 2 sine u cosine u. That's the first one. And the second one says that cosine of 2u is equal to, let me remember, 2 cosine squared u, 2 cosine squared u minus 1, or that's also equal to 1 minus 2 sine squared u. My ends kind of look like u's, don't they? Oh well. Sine squared u, and then tangent of 2u is equal to 2 tangent of u divided by 1 minus tan squared u. And these are used to, I guess, I'm not exactly sure where they're used, but they're used on your homework, okay? And they're used to find sines or cosines of, so if you know the sine or cosine of an angle, they're used to find the sines or cosines of double that angle. Or sometimes you can use them to solve, we'll do the half angle formulas, and the half angle formulas are derived from these, okay? And those are used to find sines and cosines of angles exactly that you don't normally know the sines and cosines of, which I'll talk about it. But these can be easily derived because the way they derive this is they say, like the first one, they say instead of calling it sine of 2u, they call it sine of u plus u, right? And then they use the angle addition formula just to show you where it comes from. They say sine u, cosine u, right? Plus cosine u, sine u, and then what is that equal to? That's equal to 2 sine u, cosine u. So that's where that one in particular comes from, right? But it's just nicer to have a quick formula. And then they just do some same type of thing with this, and you end up with cosine u squared minus 1. And to change this into this, you sub in 1 minus sine squared. But in any case, that's the way they work. So now I'm going to tell you Mr. Beamer's joke, if I can remember it. They said that, oh, I know that. So, no, that's wrong. Let me remember his joke. It goes like this. Okay, I remember. Is equal to, okay? And this couple walked into the bank and they looked like this, and the banker said, you can't get a loan. You know why? Why? Think about it. Why couldn't this couple get a loan?
Because they're still going to be together?
No. Because they didn't have a cosigner. They didn't have a cosigner. Right?
So it's going to bank loan.
Right. Mr. Beamer told me that joke. That's pretty good. Oh. Hey! Okay, can I get that in writing? Can you put that in writing for me so I can tell Mr. Beamer? Because we're in constant competition with his joke. He's a better juggler. Okay. So,
every day too.
But he has, all of his jokes are math related. Oh, be quiet. So anyway, we're being recorded. What?
What was your joke about 69?
I didn't have one. So anyway, we're moving on to, So then you'll see some problems kind of like this that'll say solve. And you're supposed to use these double angle formulas to solve things like this, where they'll say solve sine of 2x, sine of 2x minus cosine x equals 0. And then, so remember we had these on that worksheet a couple weeks ago, and I said skip these ones because you don't know how to do them yet. But now you know how to do them, right? So maybe I'd say solve on 0 to 2 pi, right? And so now you know how to do them, because what's sine of 2x equal to? 2 sine x. I could rewrite sine of 2x now as 2 sine x cosine x minus cosine x equals 0, right? And then what could I do with that?
Factor.
Factor, right? So you factor out a cosine x times 2 sine x minus 1, right? Did I do that right? Equals 0. Then you draw your little squiggly line and you say either cosine x equals 0 or sine of x equals 1/2. And then you solve that, right? So cosine x equals 0 where? Between 0 and 2 pi. 2 places. Right? And? Very good. Okay. And 3 pi over 2. And where is sine x equal to 1/2 between 0 and 2 pi? 2 places. Pi over 6. And, did I get that one wrong? And where else? 5 pi over 6. Okay. So that particular one has 2 answers. And, 4 answers. So if I graph that, probably just to show you kind of graphically, if I graph that, I'd get some kind of bumpy function, that kind of repeats like that. And there would be 4 places where that thing is equal to 1/2 between, right? Because it kind of bumps up and down. There'd be 4 places. I'm not exactly sure what it looks like, but it bounces up and down. So on. Okay? Another type of problem that you're going to see is cosine of theta. So they'll say something like cosine of theta is equal to 5/13, and theta is between 2 pi and 3 pi over 2, like this. And they'll say find, let's find cosine of 2 theta. They'll say find cosine of 2 theta, tangent of 2 theta. Let's just find cosine of 2 theta. Well, let's find them all. Cosine of 2 theta, sine of 2 theta, sine of 2 theta, and 2 theta, and tangent of 2 theta. Okay? So for this one, you probably want to draw a little picture. Okay? And go over here. So you want to come over here and you draw like a little tree, And, no, not that kind of picture. This kind of okay. So you want which quadrant? Yeah, my tree looks like a nuclear explosion or something. Yeah, let's erase that. I didn't do very good at art, very well at art. So which quadrant am I in if I'm doing this? If theta is between 0 and 2 pi, 3 pi, 4. 3 pi over 2. So draw a picture down here, and cosine is 5/13, so I call this side 5. I call this side 13. What do I call this side? Negative 12. Okay? And then I just plug into the 2 formulas. Well, cosine they already give me, and I have that formula that says that cosine of 2 theta, cosine of 2 theta is equal to 2 cosine squared theta, 2 cosine squared theta minus 1. I could also use the one that says it's 1 minus 2 sine squared theta, but this is easier because they already give me this. And I just plug in. So I get 2 times 5/13 squared minus 1, and then you got to be kind of good at fractions, okay? 2, what's 5 over 13 squared? Anyone?
5 over 1.
Yep, you have to square both things, okay? Minus 1, and then you don't multiply the top and the bottom, you just multiply the top, and you get 50 over 169, and I'm going to call negative 1 minus 169 over 169. Did I do that right? I think so. And 50 minus 169 is negative 119 over 169. You'll get weird answers with these problems, like big ugly fractions. Okay? So what does that say? That says if I have some angle in the fourth quadrant whose cosine is 5/13, what is the cosine of 2 times that angle? So if I took this angle and I went around again, which would probably put me, I think, in the third quadrant, then the cosine of that new angle would be this. Okay? That's what, and then let's just do tan of 2 theta. I think you could do the sine of 2 theta, but the tan one gets a little more, tan of 2 theta, I'll do it down here, is going to be equal to 2 tan theta. So what's tan theta in this case? Negative 12 over 5, right? Negative 12 over 5, and the hardest part with this for people is they don't like fractions, right? Over 1 minus negative, because it's 2 tan theta over 1 minus tan theta squared. So it's 1 minus 12 over 5 squared, right? Which gives you, on the top, negative 24 over 5, and on the bottom, you get 1 plus 144 over 25. Oh no, 1 minus, right? 1 minus 144 over 25. And if you do that, this is 169. I mean, what? That's right. So you get negative 24 over 5 divided by negative, this is 25 25ths, right? I wrote 22. 25 25ths. And if I subtract that, I get 119 again. Oh, the answer is always 119 over 25. And if I simplify that fraction, this goes away. That becomes a 5 down here. And then the way I do it, I multiply this times this, and I get negative 120 on the top. And I multiply the 2 middle pieces, which is 119 times 1. And I get negative 119 on the bottom. And then you make those both positive, and that's your answer. Okay? Get it? Okay, so that's not hard, is it? It's just plugging into a formula. The next one is kind of fun, though. And then we'll do some half angle fun. You ready to do the next one? You want me to pause?
Sine.
Take a break?
No, we're good. What about sine?
We're good. Sine. Okay, sine. You want me to do sine?
You told it says solve.
Okay, so sine of 2 theta, you just plug in, right? So sine of 2 theta, you know, is 2 times sine is negative 12 over 13, right? Negative 12 over 13, and cosine is, they give you, right? Which is 5 over 13. So you just multiply all that stuff together. And in that case, you get 12 times 5, which is 60 times 2. So you get negative 120 over 169, right? Yes? Easy enough? Okay, that's not bad. The next problem is kind of fun, I think. You won't think it's fun, but I think it's fun. So they say for the next problem, no, I'm going to write a different color. Black. Write sine of 3x. Oops, I don't need the e there. Write sine of 3x in terms of sine x. Hey, you should wake up there, Case. In terms of sine x. Okay, just dig deep here. Okay, write sine of 3x in terms of sine x. So anyone have any idea how I could do this? How I might do it? Okay, so what they do, in other words, they want you to write this without a 3. You just want it in terms of sine and cosine, in terms of just sine. Yes, what do you think there, Matt?
Put it into sine of 2x plus x.
You are a smart kid. Yes, that's exactly what you do. So you rewrite this as this is equal to the sine of 2x plus x, right? And then you use the addition formula to say that this is equal to sine 2x, so it's, you call this u, right? Here's u, here's v, okay? So sine of u, which is sine of what? 2x, sine of 2x, cosine v, right, which is x, plus cosine u, which is 2x, sine v, and which is sine x in this case. Then you use your double angle formula to rewrite this and rewrite this, okay? So this is equal to 2 sine x what? Cosine x times another cosine x, right? Because this is, I'm rewriting this as this, see? Times this cosine x, which is over here. And then how could I write cosine of 2x in terms of just sines? 1 minus 2 sine squared x. That thing times sine x, whoops, times sine x. And then they simplify this, okay? When you simplify that, this part becomes 2 sine x, cosine x times cosine x makes cosine squared x. We'll get to that. Plus, you distribute this, okay, this, and you get sine x minus 2 sine cubed x. Do you guys follow what I just did? I'm just doing algebra here, okay? Then, but they say I want everything in terms of sine, right? So, how do I change this into just sine? How do I change cosine squared x? 1 minus sine squared x. So now I'm going to rewrite this as 2 sine x times 1 minus sine squared x plus sine x minus 2 sine cubed x, 2 sine cubed x, and then I distribute this through. Isn't this a pain in the neck? 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. How many sine x's cubed do I have? I have, these are like terms, and these are like terms. So altogether I have 3 sine x's, and I have minus 4 sine cubed x's. Whoa! That's kind of, so you could do that with any multiple, like you could break it into, not that you'd want to, but you could do it with like sine 5x and break it into 4x and x and then break it up again. But it'd be a big pain in the neck. So they have these things called power reduction formulas, but we're not going to make you learn that, okay? But every time I do this problem, I feel kind of sick. Yeah, I think I'm getting a sine x headache. Maybe it's a sine x infection.
That was good.
I made that one up in second period. Thank you. I was waiting for the whole period to show that. Okay. So we're going to take a break for a second. So those are bad jokes. Sorry. So the next thing are called the half angle formulas. Okay. And the half angle formulas are derived from the. Go ahead. The half angle formulas are derived from the double angle formulas. Okay, they just kind of, instead of using instead of calling 2u, they call it u, and then you divide it by 2, and you end up with these formulas. But in any case, half angle formulas, sine, and I'll show you how these are used. These are actually a little more useful, okay? Sine of u over 2 is equal to plus or minus the square root of, I always forget, 1 minus cosine u divided by 2, okay? And cosine of u over 2 is equal to plus or minus square root of 1 plus cosine of u over 2, and tangent of u over 2 is equal to plus, not plus or minus, it's just equal to either, and you could use either one of these, 1 minus cosine u over sine u, and that's equivalent to sine of u over 1 plus cosine u. And the important thing to know is that the plus or minus, I'm not sure how to indicate that. Plus or minus depends on which quadrant u over 2 is in, okay? Not u, okay? I'll show you what I mean in a minute, okay? So, and the reason you don't have to worry about a plus or minus here is because you have a cosine and sine in the formula, and that's going to take care of this being either positive or negative, because when you're finding a cosine and a sine, one's going to be positive, one's going to be negative, or they're both positive. So you don't have to worry about the plus or minus in that case, but for these two you do. So an example of a problem you might see for this is find the cosine of 165 degrees, okay? And we did this yesterday with the summation angle formulas, right? We could say it's cosine 120 plus 45, but in this case you use the double angle formulas by calling u over 2 165, okay? And if u over 2 is 165, what would u be? 330 degrees. Yeah, correct? No, that's not the right answer. Okay? So u over 2, if u over 2 is 165, then u is 330. Okay? And then I just plug into this formula right here. So the cosine of 165, I'm going to use cosine of this formula. So 165 is u over 2. Okay? So I'm going to go cosine of 165, right, is equal to, first of all, is cosine positive or negative when cosine's 165 degrees? Negative, right, because you're in the second quadrant, okay, and cosine's negative there, so you're going to go negative square root of 1 plus cosine of u. So you don't use a 165, you use this, okay? Cosine of 330, because that's something that you actually know, the cosine of that thing divided by 2. All right? Anyone know what the cosine of 330 is? You should. It's positive. What? Root of 3 over 2. So it's 1 plus root of 3 over 2. Oh, that whole thing over 2. And this whole thing is still over the square root. Okay, and if you put this on a test and you left it like that, I probably will say that's fine. Okay, but in the book, they simplify this. And I mean, it's kind of nice to simplify it because it comes out a little nicer. You can multiply the top and the bottom of this by 2 over 2 and find a common denominator. You could rewrite this as the square root of, negative square root of 2 plus root of 3, the whole thing over 2, right? that's over this 2, right? And that whole thing is over the second 2, right? You understand what I just did? And if I simplify that a little more, I get negative square root of 2 plus root of 3, that whole thing over 4, okay? And I can pull the square root of 4 outside of the box. So I could rewrite this as negative square root of 2 plus root of 3, that thing, whole thing over 2. Now, see, it's kind of nice. This is a little nicer than this. But if you wrote this, I'm not testing you on your fraction skills, you know. So if you wrote this, it's okay. But this is better. And what does that mean? I don't know. It's just an exact answer. But if you did this as the cosine of 120 plus 45, which you could do, you would get another answer that looks very different than this, like root of 6 minus root of something. But it's still, if you put it into a calculator, you get the same thing. You know what I mean? Okay? So I have one more problem.
Wait, I have a question.
Yes, sir.
Do we have to memorize the half?
No, half angle, double angle formulas you don't have to remember. Although I kind of would like you to know the sine of 2 theta, because that one comes up a lot in like calc. I mean, I've seen it on AP Calc test. And Mrs. Hine, who a lot of you guys will have next year, will say, didn't your teacher teach you this year? I probably will give it to you if you want it on a test, but you should really kind of stick it in your brain because it does come up quite a bit, okay? Last problem. Okay, Haley, you ready for one more? Probably. Yeah, you are. Hey, it's not even hot in here. Maybe it's just all the good math we're doing. I'm sweating. Maybe I'm having hot flashes because I'm going through menopause. No. Men don't go. That's weird that men don't go through menopause, isn't it? And girls, what? Anyway. Where'd my... I just think out loud sometimes. I shouldn't do that. So, where am I? So, find all solutions. Find all solutions. This looks really horrible, but it's kind of fun one. Find all solutions on the interval 0 to 2 pi again. For let's change colors because it's not a very. It's kind of a threatening color.
Green and yellow.
What? You like green?
No, I don't.
You like
yellow.
blue?
Do yellow.
How about blue?
Yellow.
Yellow.
No, you can't see yellow.
Yes,
Try
you
it.
can. Yellow and yellow always works.
I can see that.
There it is.
We're not
Yellow's
using
the
yellow.
color.
Okay.
Clear.
Clear. Okay. 1 plus cosine squared 1 because 1 plus oh, you know what I could do is make the screen black and then write in white pen. That's kind of fun.
Oh, yeah, you should do that.
I'll do that tomorrow.
Do it right now.
No, I don't have
You're
enough
not
time.
coming
Okay.
tomorrow?
Equals 2. No, you're not gonna, yeah, I'll do it tomorrow at my house. You guys could come watch if you want.
Maybe with the
So,
Far away.
okay, so if you see something like this, which maybe you will, maybe you won't, probably not, but it's good. It's kind of good practice. What they want you to do is I'm going to leave the left side alone for now, okay? And this means the same, okay? This means the same as 2 times the cosine of pi over 2, that thing squared, right? That's what this means this, yes? And so what I do is I take the cosine half angle formula and plug it in here, and it doesn't matter whether I use plus or minus because I'm going to square it anyway. So the cosine half angle formula looks like 1 plus, right? Cosine of pi, or how come I have x's? No, that's right. Did I mess up? I'm sorry. I'm sorry. Pi over x. What am I doing?
It's not cosine.
No, this should be
X over 2.
this should be x over 2. Now, I wrote down the problem. Okay, cosine of x over 2. So this is cosine of x, right? Cosine of x divided by 2, and then I square it, okay? So I haven't done really anything fancy here. I just plugged in the half angle formula, and now I square that, and I get 1 plus cosine squared x equals 2 times, what's this thing squared? 1 plus cosine x divided by 2, and what happens to those 2's? Those go away, right? And so now I have 1 plus cosine squared x equals 1 plus cosine x, right? And then I can get rid of these 1's, and I get everything on one side, cosine squared x minus cosine x equals 0, and then I factor out a cosine x. Cosine x times cosine x minus 1 equals 0, and I draw my little squiggly line, and I say cosine x equals 0, or cosine x equals 1, and then I say x equals, where's cosine equal to 0 between 0 and 2 pi? 2 places, pi over 2 and 3 pi over 2. You guys are good, okay? And then cosine x equals 1 where? No, not at 0 radians, okay? 0, that's radians. And those are your 3 answers. Probably what you should do is take them and plug them back in here to make sure they work. Because when you square both sides, but I think we're fine. Okay. So, sorry.